to my online teaching platform, still on application of rules of differentiation. In one of our videos, we discussed the various rules of differentiation, and in one of the videos too, we considered how to apply some of the rules of differentiation. So in this video, we'll continue with the application of the rules of differentiation. So we'll be looking at functions that will require application of one or more than one application. Some questions demand application of more than one rules of differentiation. So let us start with the first question here. Suppose I have my first function to be y is equal to the square root of x squared minus x. How do I differentiate this particular function? The first thing you need to do is to express the square root as exponent half. So you need to rewrite your function as y is equal to x squared minus x in bracket having the power of 1/2. So this is the new form of the given function. So we can now differentiate this function using the chain rule. Alright. So because this is a function in another function. This is similar to composite function. So we can let the expression in the bracket equal to a given variable. So I will use u. I'm going to use u to represent what we have inside. So I will say that let u be equal to x squared minus x. All right. So it means if u is equal to x squared minus x, we can plug in u in place of the expression x squared minus x. So our new expression becomes y is equal to u in bracket having an exponent of half, right? So can now differentiate our function u in terms of our function y in terms of u. All right. So we have two functions, and we have a function u in terms of x and another function y in terms of u. All right. So we are going to differentiate the two functions. So we'll be finding our du dx, that is, we are differentiating function u with respect to x, and this will give us 2x minus 1. So this is our function u. This is our function u. So this is what we have differentiated to get 2x minus 1. We have used the power rule to differentiate the function u to get 2x minus 1. All right. So let us now differentiate our function y in terms of u. So our dy du will be equal to, bring the power down using the power rule. So the power, which is 1/2, will multiply the given expression. Then the power here will be reduced by 1. All right. So let us continue and get our derivative. So this becomes our dy du becomes 1/2 of u having an exponent of negative half. All right. So this becomes our dy du. Right. Now we have to find dy dx. All right. So we will be multiplying the two functions that we have differentiated. We are going to multiply their derivatives to get our du. Sorry, our dy dx. Sorry. So it's going to be our dy dx will be equal to the product of the two derivatives. So we have dy du times our du dx. So you will say that when you simplify what we have at the right hand side of the equation, you get back to what you have at the left hand side of the equation. So the left hand side is the same as the right hand side. Now let us bring back the components. So we have our dy du to be half of u exponent negative half, multiply our du dx, which is our du dx is here, so which is 2x minus 1. So we are going to replace du dx with 2x minus 1. The terms are 2, so we put them in bracket. All right, so this is what you'll be getting. So we are going to get 2x minus 1 in bracket multiplying 1 half, which is the coefficient of u exponent negative half. So we are going to now get our u exponent negative half. Then we are done with what you are supposed to rewrite. All right, so we will expand the bracket with the half over here, the exponent half. So it's going to be 2x times half will give us x. Then negative 1 times half will give us negative half. Then they should be in bracket nicely. All right. Now we bring our u exponent half again. So we continue to simplify. Now we should know that our u exponent half can be written as 1 divided by u power half. So we have x minus half in bracket multiply 1 divided by u exponent half. But we know our u to be, but the value of u is, but u is equal to x squared minus, I think, let me go and check again. The value of u is equal to x squared minus x. So we are to bring back the value of u, which is x squared minus x. So whenever you see u in the new expression, you plug in x squared minus x over there. So our dy dx will be equal to, as we already have x minus half in bracket, then you will now replace your u with x squared minus x, and the u is having power half, so you bring your power half outside, and this will give us x minus half in bracket multiplying any number having a power of half is the same as the square root of the number. So we have 1 divided by square root of x squared minus x. Now you can see that we have x minus half in bracket multiply 1 divided by the square root of x squared minus 1. So we can multiply through. So we are going to get our x minus half as the numerator divided by square root of x squared minus x. So this becomes our dy dx. Thank you for watching, and please do not forget to subscribe to my YouTube channel, Math with Ebefa. Bye.